In our lesson today, we looked at Theorem 10.12, tangent lines at the pole. If f of alpha is equal to 0, in other words, you have a point at the pole, and f prime of alpha is not equal to 0, then the line theta is equal to alpha is tangent at the pole to the graph of the polar equation. And we looked at this particular example where our polar equation is f of theta is equal to 2 times cosine of 3 theta. We set f of theta equal to 0, solved for theta. We found that the solutions were theta is equal to pi over 6, theta is equal to pi over 2, and theta is equal to 5 pi over 6. And those are the three tangent lines that you see sketched here in blue. Theta is equal to pi over 6, theta is equal to pi over 2, and theta is equal to 5 pi over 6. That was done correctly in the lesson, during the lesson, but I made a mistake when I was trying to explain the particular tracing of the curve and how you get these tangent lines as the curve passes through the pole 3 different times. I had that incorrect, and now I'd like to correct that. So let's go ahead and take a look over here at our polar equation. R is equal to 2 times cosine of 3 theta. And you can see that I've added a slider for theta from 0 to a. And I would like theta to go from 0 to a. And the range that I have for theta is going from 0 to pi. So now, because I have this particular condition, I can manipulate the range for theta for which the polar equation will be graphed. So we start at theta is equal to 0. And as I'm tracing my slider, you can see the curve being traced out in orange. And first, I'm going on the interval from 0 to pi over 6. And on that interval, the R values are positive. So I'm getting points on the terminal side of my angles. On the terminal sides of my angles. And then I get to theta is equal to pi over 6. And when I get to theta is equal to pi over 6, I pass the pole for the first time, and this is the tangent line that I get. The line theta is equal to pi over 6. And then I keep tracing, and after I pass pi over 6, the R values from my polar equation become negative. So now I have points on opposite rays from the terminal side of my angles when my angles for theta are between pi over 6 and pi over 2. And then I get to theta is equal to pi over 2, and I get this tangent line at the pole, which is a vertical tangent line. And then I keep going, and when theta is greater than pi over 2, R becomes positive once again. So I have points on the terminal sides of my angles. And as theta approaches 5 pi over 6, this is what we're seeing. And when we get to the pole, theta is equal to 5 pi over 6. So here is my third tangent line. Theta is equal to 5 pi over 6. And as theta goes from 5 pi over 6 to pi, R becomes negative once again. So I have points that are on opposite rays from terminal sides of my angles. And when I get to theta is equal to pi, I complete one loop, giving me 3 petals of the rose curve.